VCC connector for the first chip. Ah crap, I should have measured the length. Oh my god. Oops. I'm alive. I'm okay. I kicked over my trash can. Hello everyone. Welcome back to the stream. If you have been here the past 2 days, then you notice that I'm sitting in a different environment here. I've rearranged my room because I was unsatisfied with the place how I was working and like the general setup. And so yesterday after the stream I spent a couple of hours completely rearranging my setup, and let's see how it works out. Maybe the angle is a bit weird because this is where I would usually work on these two spots here, and here I have the setup now for building the 8-bit computer that we are building, but I have way more space now, as you can tell, and you don't quite see it here, but let me show you the top down camera. So this is now, I think, looking much better, and we can then also move the camera forward where we then have the oscilloscope and also the power supply and stuff like this. So if we look at some stuff, we have the oscilloscope right here in view. That should be great. Yeah, that's about it. That's the new setup. Let me know what you think. Awesome. Are you later going to program a compiler with a higher level language for the computer? I'm not sure if that will be possible with this version of this computer. I haven't looked at it in detail because I'm just following the series now. I haven't watched the videos beforehand, but I read a few pieces here and there, and my understanding is that the instruction set is extremely limited on here, and I mean you have to implement all the instruction in hardware yourself. So basically, as far as I know, Ben Eater has just implemented a couple of kind of important instructions, but then again, this machine only has 16 bytes in the default configuration. 16 bytes, which allows you, a few bytes for instructions and maybe a few bytes for memory as RAM, right? So he has this Fibonacci program that uses like 14 bytes or so, or 13 bytes, and then it uses like 3 bytes as memory to store the current value of the Fibonacci, for the Fibonacci algorithm, right? The temporary variables. So there's not much space. Can you recommend any CTF challenges for beginners? I'm not so sure. I mean, I think the Exploit Education series, what used to be Exploit Exercises, is a great series to start, and you have my videos that help you when you get stuck. So you can, watch some videos and try it yourself and stuff like this. So I think that is hopefully a good experience. Otherwise, I think also Pico CTF is probably a good place to start. I think these are good places.
That'll pull this down to 0 volts, and 0 volts, of course, is below 1.6 volts, and so that'll set the flip-flop, and the output will turn on.
How much do the components of the computer cost? It's, again, check out the parts list on Ben Eater's website. It's roughly $250, plus minus, depending on where you buy parts. I paid roughly 240 euros right now, I think. The most expensive parts are the breadboards. I think the breadboards alone were easily like 120 euros or so. Different questions. Have you been at the Cybersecurity Challenge Germany in the past? Yeah, I played it 2 years. Has anybody understood like the difference between the previous debouncing circuit and now the one we built right now? Oh, Procker, thanks for the subs again. You gifted some subs already yesterday. That's absolutely not necessary, but thank you so much. Maybe because you need to debounce both states here, and previously only had to debounce the on state. Yeah, I'm sure you are right. It hasn't clicked yet in my head, but that also is the only thing that makes sense to me. Oh wait, they are here. Black, red, and this greenish color. All right. if I remember correctly, he said you could use the old debouncer too. Oh, he did say that in the video? Actually, wait, maybe he did say that. Wait, let me see.
Really frustrating. So we really should find a way to debounce this switch. And you could build exactly this circuit, and that would work fine. I'm going to show you a different way
There it is.
to use the triple.
You are right. You were right. Awesome. Thanks for pointing that out. Lazandre. Thanks so much for pointing that out. That was very helpful. Okay, so it wouldn't matter if we built the same circuit. He was just building another version of it. Okay, so what else do we need? We need the switch. So let's see, I bought these switches here. Let's see if they work out as intended. Thanks for the sub, Alice Cool, Alice Bestons. Look, we got emotes. We got one emote. It's the glitch. Again, can just shout out again. Soding is very active streaming. Streaming C++. It's also very interesting and entertaining. I can recommend to follow. A white rabbit. That's a good idea too. I haven't thought about that. Yeah, that makes sense. We totally need a white rabbit. Who of you are not from or who of you don't know Club Mate, by the way? 1 in chat if you don't know it. 2 if you know it. Way too many ones. You really need to travel to Germany with some time. It has a... You can look it up on Wikipedia. Oh, goddammit. Club Mate. Clubmate. Yeah, it's a high caffeinated soda drink. It's based on mate tea. But it's like why I'm mentioning it is not because it's an interesting drink, but because it's like part of German hacking culture, and so it's very popular in the German hacking communities. And I think it's even mentioned, at least on the German Wikipedia, it's mentioned that it has its like big origin kind of in the German hacking culture. You got through 35C3 without drinking mate once. That is pretty impressive. Oh, the cybersecurity challenge. Yeah, not the best challenges in that event. Definitely not. I should buy a wire stripper. Yes, indeed. We talked about it yesterday on stream. Some people recommended some wire strippers for me, and I ordered one. Hopefully arrives. I don't know. Maybe even tomorrow. Otherwise, sometime this week. Yeah, the challenges are most of the time guessing. Yeah, it's not a good CTF. However, like the good thing about like why I still liked the CSCG was because I met a lot of amazing people that I'm still that have become really good friends of mine, and we have basically our CTF team formed through that, and so that's why I really, the CTF might be shit, the challenges might be crap, but in the end there's a community around it with people, and I really enjoyed that. You're participating since around 2015? Maybe then we have interacted before. I didn't play as liveoverflow during that time. Okay, this could have been bad. I just realized I plugged in the resistors in the wrong pins. Any idea where I can get into electronics? Probably would be better to start with something simple and useful rather than a whole computer. I mean, to be honest, like following the series I think would be a great start. But otherwise, just like, I mean, I don't know what a good entry is, right? I'm not a professional. As a hobbyist, I can tell you that I thought that doing Arduino stuff was really helpful for me. Just getting like an Arduino starter kit and trying to build something with that. I also think like small stuff, maybe you can, like there are these kind of Arduino compatible things, I forgot their name, but they have Wi-Fi included. So that makes it very easy to kind of integrate with like your home network in a way that you can, for example, send commands from your computer over Wi-Fi to that chip, and then you can like control like some LEDs or something like this. I could imagine that that could be like a cool project to learn the basics. I don't like the German system, to be honest. I wish we would make it much easier for people to go to university. As for example, also if you had Realschule before, that you can just like prove yourself in a certain way and like do an entrance exam, and then it would allow you in. I mean, make that entrance exam hard, I don't care, and make people be able to study. But if somebody spends like a year or so studying towards that entrance exam to learn it and then to get into studying later in their lives, I think that would be so important. I don't like our system, to be honest. Anyway, I think we implemented this. Let's plug it in and let's see if it burns. Yes, I think should be fine. Okay, so those circuits still work, so that's good. Oh, Adam, thanks for the host. You should also, everybody, check out Adam. Adam is developing for a super long time now already, like a browser game about automating bots and fighting against each other. And he's really great at streaming. I cannot comprehend how he can program and interact with chat so well as he does. It always amazes me. And he has been doing it for such a long time. He's super helpful and nice, and you should definitely check him out. Okay, so yeah, this at least seems to work. This switch allows us to change the LED. That's very exciting. You should connect it to 230 volts. That will give those LEDs a little bit more oomph. True. Yeah, so welcome everybody from Adam's streams. It's very exciting here. We just finished this amazing circuit that allows us to control this LED with this little switch. It's thrilling. It's absolutely amazing. We can also press this button, which turns this LED on when we press it. It's incredible. Okay, cool. So we have been streaming for over an hour. I think we can definitely head into the second video as well. Let's see. Oh yeah, I wanted to check if I have a different switch than this janky one here. Maybe this one here. We would have to solder this on something else. I don't. This wouldn't fit in a breadboard, and these are way too thick. But maybe we can find a better switch some other time. I need to order a different potentiometer anyway, because this one is like so huge and long. It looks ridiculous. I want like a nice small one that also better fits on here. So I have to order some more parts anyway for that. Yeah, that's a great thing about Germany. Our infrastructure is so well that orders will come like directly in the next day. However, I will probably order from Reichelt, not from Conrad. Still better than the US though. Like because the US is so large, like it's typical that things need like 3 days, which sounds horrible to me. How can you live without Amazon Prime next day delivery or same day delivery with Amazon Prime now?
Now what we need to do is just combine these three signals here into a single clock output signal for a clock circuit. Makes sense, but you might want to leave these other LEDs here if you want. But I'm gonna take them out, and then of course we can take out the resistors here as well. That leaves us with this, and so this is going to be our finished clock module. Plug the power back in so we can see, we can run it, we can stop it, we can pulse it, and if the computer halts it, then it doesn't matter what we do, it's halted.
More LEDs are always better. Yeah, it was hurtful to see him rip out all those LEDs. That's blasphemy. If you watch this video, you get what these black magical chips are. I think like this is kind of like a learning experience for me, you know, for the first time when I did like electronics. You always look at like PCBs and you see these black chips and they are so mysterious. Like what are they about? Like what's in them? And so understanding that, you know, in this case, for example, this 3 shown here on in Ben Eater's videos, 3 laying there on the paper, they are just chips that implement different gates. So they just have this transistor logic in there to implement an AND or an OR. And there's nothing really crazy about them. That's just what they do. Yeah, the hex inverters. Okay, 04, 08, and 32. Let's see. Okay, so here we have the 04. Uh, 8 and 32. Oh, 8. Those are the AND gates. Oh, these were in here. I'm stupid. Yeah, 32. I'm looking for 32. There we go. When you finish, make a PCB out of the design. Yeah, that's another thing. I'm sure people have actually done that already. And that actually would be cool to have like a big board and you solder it and it blinks and you can kind of rearrange that. That would be also kind of a cool project. Yeah, I kind of like that idea. Why is your energy so low? What are you talking about? I'm like really trying to be more active. It's really straining. I don't know what to tell you. Like I'm way more upbeat right now. I really try to be like really active. In real life, I'm even a bit more chill than that. So if that's if that is low energy to you, then watch yesterday's streams. I think like today I really try to be a bit more. I checked out like my own stream yesterday and felt like I was a little bit too weak to be entertaining for Twitch. So I really tried to be a bit more on it today. But I guess it's not working. So which one is which? So in the front we have the AND gates. We need to look up the data sheet as well, that we know which port is which. Perfect. Okay, so we start with the AND gates, which is 08. And this is the diagram. 3 from the switch and 3 from the clock at the start. Wait, what's about smart contracts? I never really understood smart contracts. Yeah, that's also like a to-do on my videos, like that I would like to make videos about at some point, like some smart contract tutorials or something like this. Not because I'm not into, I feel like I need to always say this disclaimer, like I'm not interested in cryptocurrencies at all, and I think most smart contract stuff is all scam, or everything is a scam basically. But I do find smart contracts from like just like a computational standpoint, from like a computer science standpoint, really fun. Like the same way we are building a stupid 8-bit CPU to execute some stupid instructions, I think it's fun to see like a smart contract execute instructions on the blockchain. It's just a weird... Oh, fuck. Oh my god. It's just a weird execution environment, which is kind of fun. I really need that wire stripper. Well, basically the fact that it is transparent, so everyone can prove that you did a certain transaction or own a certain token. I mean, there are other ways to prove that as well, I know. You can't do gambling on a smart contract though, because it has to be fully deterministic. There's no randomness. But you can't really know at which point your code will be executed. Therefore, you could include certain that in the hash, which make it unpredictable. No, well, that's the thing, you know, like that's true that it kind of makes it a bit hard, but in the end, it's like not cryptographically great. Like, right, the miner that finds a block and decides to include that execution in the transaction or not, knows the hash and can decide if it will execute that or not. And if that miner is participating in the gambling, the miner can check, would I win with that hash? Nope. Then let me not include it. I mean, so for example, what bothers me the most with a lot of the blockchain smart contract stuff is that first and foremost, they sell it in their marketing material as this amazing like technology, right? And so the main focus should be on developers, like explaining the technology, how to implement it, good example applications, stuff like this, right? And then you go on these blockchain websites that explain their new blockchain technology. And there's a lot of marketing blah blah, how their blockchain is so fast and how their smart contract system is so much better and that it solves all these problems that the other blockchains have and it's all magical. And then they have a technical paper and they have a white paper and you read it and there's just literally no technical information in it. It's like high level abstract bullshit, no actual details, and that just tells me everything. So 4 and 5. 1, 2, 3, 4 is one and 5 is the other one. And 5 from here. And then the inverter is on to the output. So what is the maximum speed? That's actually a good question. When we have finished setting this up, I actually want to measure the maximum hertz that this clock module runs at. We actually don't know right now. Or I don't know. Thanks Intel Pentium 4 for the sub. You are definitely faster than this 8-bit CPU that we are building. You made this for a school project and it took me so long. Don't be intimidated by the wiring now, it gets much worse near the end. Yeah. Well, I don't mind if it takes a while. I'm kind of looking forward to it, to be honest. What is your goal with this project? Yeah, just to build it. It's an 8-bit computer. It's to learn more about electronics and I have somewhat of an understanding of how a computer works. But actually seeing every single component, because there are a few parts that are still a little bit confusing to me, especially like the execution of like instructions and how the bus works. I mean, it's not not quite as complex as modern CPUs do it. It's a simplified version. It's based on the architecture of SPA, simple, or SAP, simple as possible CPU. And so, so I hope to get a better understanding, to learn more about electronics, and just to have fun, I don't know. Twitch auto-moderated the term cable stripper for obvious reasons. Yeah, I know. I put it on. It's on my. I ordered it from Amazon. Maybe it comes on. Not from Amazon. I ordered it. Where did I order? I ordered it from somewhere. I hope it arrives tomorrow, but maybe the day after tomorrow. But practicing stripping cables with just a clipper is maybe also a skill you need. I don't know. VCC connected for the first chip. Ah, crap, I should have measured the length. Oh my god. Oops. I'm alive. I'm okay. I kicked over my trash can. Oops, that was way too long. Oh, what am I doing? Oh my god. Didn't you hook up GNZ? Yes, I did. Oh man. What an idiot. So 14 up here. Oh my god. Okay, so we had some short circuits last time, but luckily I have here the like a power supply with limiting current. I'm not sure what I set it to, but maybe we could have been fine. Not sure. We could have been lucky. That's one thing that I kind of want to try out. Like if we can glitch the CPU with a much higher clock rate, like when it's all set up, like when it's all working and stuff like this, and we can actually write a bit more code, we have a loop, and then I wonder if we can glitch it to break out of that loop, like as an attack. That would be kind of cool, I think. We should try that, and maybe we can like observe this, you know, like we can maybe we find a good point where we can measure with the oscilloscope and see basically when the glitch happened and why it happened or something. Oh my gosh, it is connected to pin 6. Thanks so much. Chat has really good eyes right now. Amazing. I feel so confident about this build now because I easily make stupid mistakes like this, and so that you notice is very valuable. Okay, and now we only need to have the output. So we need a blue LED. Do I have blue LEDs? I think what I need is to have like a smoke detector that is connected to some alarm wires, and if we ever trigger the magic smoke in this build, then we could have like this amazing light show. I think that would be cool. Yeah, the wire was shifted weird. I think it might be shifted up a bit. He was also doing a negative clock signal going down again as well into the inverter. Oh yeah, I know about the teleportation of stuff, of electronic devices on the floor. I mean, that's what you get if you work with magic. You know, sometimes your magic smoke escapes. Sometimes the aliens take your components back. That just comes with the topic. Okay, so now we have the resistor for the LED, and now this output also has to go into the inverter for the inverted clock. Oh my gosh. Okay, everybody ready? It could blow up, so pay attention. Here, let's get the screen out of the way. I take safety. Okay, something is wrong. This LED should not stay consistently on. No, wait. Oh, sorry, no. This LED, sorry, I'm confused. This LED was the switch. But clearly this output is not working. Okay, so nothing is blowing up. This means we can debug it at least. Connect the hold line. Oh, do we need to connect that? Wait, the hold line should be connected to plus, right? To VCC. No, to ground, because then it will be inverted. I installed an IR light. Yeah. Okay, cool. So it's blinking according to the clock. Nice. Okay, now we do the switch. It's off. It works. Now it's our button press. We put it back and we have the clock. We put it here, button press, and clock. There we go. There's a lot of noise. So ignore the blue one. Let's disable that. But cool. There we have our clock signal. Is that noisy? Does that look bad? Currently we run at 18 Hertz. This is 200 Hertz. So we have here the measurement screen. It's too small for the stream, but here is a frequency calculation. So it shows here the frequency that it measures. And so currently it's 300 Hertz, 380 Hertz. Okay, 500 Hertz is the maximum. It is running with 500 Hertz. Let me quickly move over, plug in the second one to check if the inverted clock also works. We haven't tested that yet, but we should see this here easily with the second probe. So let me turn that on. We don't see anything. Great. Oh wait, is that maybe not quite in? It has like a weird level too. The LED pulsing because of the shut. Oh yeah, true. Wow, that's cool. It's actually super fast. Right now it's 30 Hertz, 30 times per second, but the pulsing. So I almost matched the FPS rate, but not quite, so it was pulsing slowly. That's 34 Hertz right now, so it's a crystal. Well, the problem is with the crystals are super fast. I don't know what the minimum frequency of a crystal is, but we want to see the CPU slowly executing. We want to see each clock cycle slowly. How does a clock interact with the CPU? I mean, you can watch Ben series, but it basically comes down to the flip-flops that I'm really not sure how to explain that. I'm also obviously not knowing it quite. That's also why I want to build this, to understand it better. But how I imagine it right now, or how I think about it, is that a lot of these electronic components, like in flip-flops, they might react on like a rising edge to set a certain state. And that state can then slowly propagate always, and that state can like influence the next state and stuff like this. And the clock with the rising edge always tells the circuit to now set the output. You have something on the input waiting for the rising edge, boom, set the output. Next clock cycle, set the output. And then you have a lot of logic gates, and then each rising edge, the state is propagated one forward. That's how I imagine it, but I'm not sure. Also, my understanding, again, the reason why I want to build this is to understand it better. But as far as I know, a single clock cycle or a single clock tick is also not executing a single instruction, because instructions require multiple cycles to be executed. In modern CPUs, it's very complicated, but in this basic CPU, as far as I understand, we have a defined row of cycles, and it might be like the first cycle we fetch the instruction, the second cycle we kind of like decode it or something like this, in the third cycle we set the register values, the fourth cycle will check if flags are being set, and I don't know, like something like this. In modern CPUs you have also pipelining, so you have you don't need to wait 8 clock cycles to fetch the next instruction. You can always use fetching in every cycle, and you will pre-fetch the next instruction already. So that you can parallelize it, and that's then pipelining, as far as I know. No, wait. If we measure the clock cycle down here, so this definitely must go in. So why does it not show us the output on 12? Oh wait, do we need to... Can we not measure just the output here? Do we have to make a connection? Do we have to put like a pull up resistor there? Yeah, like a 1K resistor, we should be able to measure something. Is that correct? Or will I fry something if I do that now? Okay, I put there a 1K resistor. If it burns up, it's Pro GJ's fault, and you will be banned. Wait, does it have... No, I have to connect it to ground, right? No, wait. Here it's just... Okay, wait. This is consistently just high, or consistency low. but I would assume you don't need it because that also makes sense. Okay, so why is the inverter not? Should I try? Wait. Let me check again. So the inverter is here. So I'm connecting to pin 13 and 12. So the chip itself must have power because other parts of the, like on the other side we have an inverter that is has output going into one of the gates here, and the thing works. So it should be working. But maybe, I mean, it could be that this single gate is broken. So maybe maybe we try the next one. So I wanted to take this output now into the other, in the second inverter here, and suddenly I'm halving this. Do you see that? What is up with this inverter here? Why is, when I am in, wait, is the pin out? Am I just fucking up the pin out? See, the LED is consistently on. Okay, that's shitty to see, but okay, so here you should see the output where I'm plugged in right now. That should be pin 9 and 8 of the inverter, all the way here over here. And 9 would be the input, and the LED is on pin 8, the output. And it's just consistently on. Are you sure that this is the inverter I see? Are you sure that this is the inverter I see? Are you sure that this is the inverter I see? Are you sure that this is the inverter I see? Oh shit. Thanks for the sub, false honesty. Yeah, it was the wrong chip. And I thought, wait, but now I have introduced some other bug. Can I do Control Z and go back and undo what I just did? Why is it not working anymore? What did I screw up now? Turn off the power before changing things. YOLO. Yeah, maybe did I now fry a chip accidentally? Okay, so recap. Sorry for the silence. I was so annoyed at myself. So indeed, I connected to the wrong chip. This here is the inverter, and so I thought I just hooked up an inverter there and turned it on, and then suddenly the clock was broken. Now I ripped back out the cables again in the hope that that would fix the clock, but I think I just screwed up something else now. Oh, I think I ripped out something that I shouldn't have ripped out. I need the schematic again. I ripped something else I shouldn't have ripped out. Oh my god, now it's the stream so much over 3 hours again. Well, oh man, I'm getting annoyed. Sorry. Hold! That's what you mean. I understand what you're saying. I know what you mean. Hold. It's blinking again. Oh, god damn it. Thanks, David Panic. And thanks, Toby. Yeah, Halt was missing. I was screaming at the screen. I'm so sorry. My god. Oh my god. Okay, great. So now let me fix this again. Okay, let's see. There it is! The inverted clock. Okay, so now the inverted clock works. It's always the inverted state. And that's how you build a police car. Okay, one last measurement, just curiosity, even though we probably don't measure much. I want to measure the difference from the output up here and the output down here after I went through all the logic gates. Probably we don't see anything, but I'm still curious if we do. Like, I just want to have it measured just to know that it has no effect. The stream is hardware gore. Oh, I'm sorry. Why is this half? Oh, wait. Oh, scaling. Sorry. Ignore me. It's the scale. There's no really measure. I mean, there's no really a delay. What scope do I have? It's the Rigel DS2072A. It's the one that you can unlock. It has originally 70 megahertz, but you can crack it to, I think, 300 megahertz or something like that. The edge is so ugly. Well, we are also zoomed in like crazy right now. So the time division right now is 50 nanoseconds. So each square here is 50 nanoseconds. Now each square is 10 nanoseconds. I mean, what do you expect? Now if you go like, that edge disappears. Now we have 2 microseconds. Now 5 microseconds. But if you are looking for an oscilloscope, so I bought this because I used it at university and I liked it and I knew you could open it up. However, like about a year after I bought this one, Keysight came out with an entry-level scope that has I think on better specs than this one not cracked, which is I think even cheaper and has more megahertz, also dual channel I think, or maybe even more. You need to check again. But what I remember was that if that would have been out when I thought about buying this one, I might have gone with the Keysight instead. Oh, there was another subscriber 8 minutes ago. I missed it. I'm sorry. John Hammerling, thanks for the sub. I need to start building my 8-bit PC. I have all the components ready. Nice. You should. Another energy drink and go for the registers. Yeah, I wish I could do that. Yeah, Benita retweeted or responded or something on the stream. That made me really happy. I mean, with that modulator thing that you send 3 times a clock fast and then wait a bit, then 3 times fast to see the next instruction directly. Oh, I think I know what you mean now. Because, like, let's say each instruction takes 3 cycles. You mean that you can send all 3 quickly as as a kind of like a single step, and a single step is 3 clock cycles, for example. I guess that's what you mean. I don't know if is Ben either building that. If he's building that, then I will also probably build it. On the other hand, might also be a fun debug thing, maybe, to have like that would be quite a challenge. I don't know. Like that sounds simple enough that it should be doable, but definitely hard enough for me. I would not know how I can make a single click and have it followed up with 3 clock cycles. I don't know how you build that with a circuit. Is that easy? Yeah, I don't know how something like that works. Would you need to have a small counter, like you always set like 2 flip-flops to the value 3 and have it like decrement or something like this? I don't know how you would do that. That would be maybe interesting to learn. With counters, I guess. Yeah. More 555s. Yeah, I was also just thinking, could you maybe time it with 555s? I don't know. Like you have one 555 generate just a regular unstable pulse, right? But have another one that is ending that one. So you have it on for always 3 times as long as the first one. That could also maybe work. That sound reasonable what I said? Basically we combine this one here that just stays on longer and will always stay on 3 times as long as this one here, and then you end the 2 together, and then you should have 1 click should always output 3. Is this gonna be on YouTube? It will be unlikely be a live overflow video, just because why would I make these videos that Ben Eater has already made? Makes no sense. I think it's fun to have like a live stream instead about it. I see a bit more value in that, I guess. Maybe I will do like a summary video when it's done, maybe, for live overflow. However, all the videos will be in the Twitch archive, and also I will upload them on a second channel called Random Overflow. You can find the link to Random Overflow channel on the Live Overflow channel when you look in the sidebar in the featured channels. This is where you can find just the recording of these streams. Okay, all right. Thanks everybody for joining me today. Thanks so much for the bits and the subscriptions, and most likely see you tomorrow continuing building this. Have a nice evening. Keep on learning, and see you soon. Bye bye.